Hello everyone, and welcome back. In this important lecture, we will talk about the Elasticsearch Terms and Structure. So, Elasticsearch is a powerful search engine used for storing and retrieving data. In this presentation, we will cover some of the most basic terms and their structure in Elastic. So, Elasticsearch is a NoSQL database that you can store and query large amount of unstructured and semi-structured data. Elasticsearch is a schemaless, allowing for dynamic mapping for fields and flexible data modeling. Elasticsearch supports nested and multi-valued fields, making it ideal for complex data structure. So I can have in SQL we have tables, but in Elasticsearch we work with documents. A document. A document is a JSON object that represents a single instance of data within an index. Each document is identified by a unique ID, which can be specified when the document is created or generated automatically by Elasticsearch. So in Elasticsearch you have unique ID. In SQL you have like primary column or primary key. Documents can contain fields of various data types, such as string, numbers, and date. In the next lecture, we will talk about the fields type. So, in this example, we are making a post response to the index name NBA players. We're creating a document, you have the underscore doc, and we have 5 fields. The first one is insertion to Elastic. It's a field type. It's a date type. The second one is first name. The third, last name. The fourth, date of birth. And the last one is position, is keyword. So, an index. An index is a collection of documents that are stored and indexed for searching. Each document is a JSON object that contains key value pairs, where the key represents field's name and the value represents the field's value. For example, an index might contain documents that represent product, which fields such as name, description, price, and category. Indexes can be divided into shards for better performance and scalability. For example, in SQL we have table, in Elasticsearch as NoSQL we have index. Mapping. A mapping is a schema that defines the fields and data types for a specific index. Elasticsearch uses a mapping to determine how data should be stored and indexed, which allows it to search and analyze data efficiently. Mapping can be created manually or generated automatically by Elasticsearch based on the first set of documents that are indexed. I highly suggest you that you will pick the mapping. You will make a mapping API to the Elasticsearch server and you will choose wisely the field type. Mapping can also be updated as needed, allowing you to modify the fields and data types for an index. Let's see an example. In this example, if you remember the NBA players that we already saw, this is the NBA players index mapping. As you can see, we have mapping, and then we choose for each field name is type. Insertion for Elastic will be with type date, and we also choose the date format. Field name will be text, last type will be text, date of birth will be date, and position will be keyword. In the next presentation, you will see the difference between text and keyword. The next term is index template. An index template is a configuration file that defines the setting and mapping for one or more indexes. Index templates are used to automate the process of creating new index the same configuration, making it easy to maintain constantly across multiple indexes. An index template can define mapping, settings, alias, and other configuration that will be applied to all new indexes that match defined pattern. For example, the last example we saw a mapping for NBA players, but now we are creating a mapping for all the index names that start with NBA players, and we can see the star. Like if you will want to create an index for every day, so NBA players underscore the date, and the date for tomorrow will be different. So we can create a template that will create the same mapping over and over again for a different indexes. So NBA player stars will create the index mapping for every different occasion. Shard. A shard is a subset of an index that contains a protean of the index data. Shardings allow to Elasticsearch to distribute the data across nodes in the cluster, providing a better performance and scalability. By default, each index divided into 5 primary shards, but it can be changed depends on the size of the data. Let's see an example. Here we have an index. The index are containing 1 terabyte of documents, but there are shards. In this occasion, we have 4 shards. Each shard A, B, C, and D, contain the same amount of documents. Each shard contains 256 gigabytes of document. Replica. A replica is a copy of shard that provides high availability. Replicas are created automatically when an index is created, and they can be configured and provide fault tolerance and load balancing. Elasticsearch automatically balances the load between the replicas and primary shards, ensuring the data is always available, even if one or more nodes in the cluster fails. So let's say you have the cluster and you have 2 nodes, and one node is fail. So in this occasion you have the replica shard that contain the same documents as the primary shards. We will see an example. Node. A node is a single instance of Elasticsearch that stores data and participates in indexing and search operation. Each node in the cluster is identified by a unique name. Node can be configured with a specific settings such as the amount of memory they can use. A cluster. The cluster is a collection of one or more nodes. This is the big entity. Each node in the cluster is responsible for storing and processing data. Node can be added or removed from the cluster. Elasticsearch clusters can be made of one or many nodes, which make it highly scalable. Let's see an example. So here we have the big cluster. In the cluster we have 2 nodes, node A and node B, and inside each node we have shard A, shard B, C and D. But in node A we have the primary shards of A and B and the replica shards of C and D, and in node B we have the exact opposite. We have the replica of A and B and the main of shards C and D. That's why if the node A is fail and deleted from the cluster because of a fail operation, we have node B with the same document as node A. Okay, so that's all for today. We spoke about mapping, about index, documents, index templates, node, shard, primary shards, and we see an examples. Okay, thank you very much, and I see you at the next lecture. We will talk about field type. Thank you very much, and have a nice day.